right? So let's begin with the no Amazon Aurora, right? So this Aurora is like something designed from very scratch to run in cloud environment, right? So this is another type of no a SQL type of database, right? So initially when you just came to that database thing, so it was asking for some Aurora, right? So it's
Yes.
some no, it's compatible with MySQL and Postgres actually. So MySQL and Postgres compatible relational database. So SQL type it is. Migration support, fully managed, high performance, highly available, simple, cost effective and all. So as soon as it is fully managed, right, you can think of all the benefits, right? Right. So if you have any MySQL or Postgres, right, running in your on premises in your no data center, right, and if you are planning to move those no MySQL or Postgres to Amazon, right, Aurora can be a very good option. Okay, so you'll have that migration support also. Database migration service will be there, so there you get migration support as well, right? And no, it's good actually. It's from the it's mainly built for no, cloud, so it is uh, very good actually. So it's fully managed by Amazon, right? And because of that, you have all those features, right? So it's kind of, you can say, no, fully managed another no RDS. So you don't have to worry about all those provisioning and all those no software patching and taking backup and doing a lot of other things when it comes to fully managed service, right? So it will back up again like no your database to S3, right? And no, it will use that CloudWatch, like how you did that CloudWatch things, right? So similarly, it can do that. It can monitor the performance of the database, right, using that CloudWatch, right? And on the same hardware, people have been saying, right? Say like whatever hardware you are having, so as compared to that MySQL, have MySQL running on a particular hardware, right, with the some kind of CPU and memory and something. On the same hardware, if you run this Aurora in place of MySQL, right, it will give you 3 to 5 times better performance. 3 to 5 times better performance on the same hardware. You can just think, right? So we have storage up to 64 terabyte, right? Auto scaling will be there, and you will have 6 copies, right, of this storage across 3 availability zones, right? So you will have 6 copies, right? You see data copies 2 to 6, correct? So you have like no primary instance. You see this reads, writes, right? Writes, primary instance writes, right? Then reads Aurora replica. Primary instance, Aurora replica, Aurora replicas. 1, 2, 3, A, B, C zones, right? So it is like no awesome thing, right? So where do you find it? Where can we find this Aurora? You have to go to console, right?
Yes. While creating the database itself, we found Aurora.
Yeah, here only it was giving
Yeah,
the
yeah.
advertisement.
Yes.
So usually last to last month also, I have been seeing Aurora. They are advertising this a lot. So they say like no, it gives some 3 to 5%, 3 to 5 times better performance. Right. So we can simply click on database, and how we have been doing that. No, from here you
Yeah.
can go, right, or then you come to the same page, right?
Yeah.
Or you can go to database and then you can come. So like this you can come. The first thing is by default Aurora only, right? So you just choose that Aurora in place of that MySQL, and whatever you wish, you one by one you can try out everything, right? So you see Amazon Aurora with MySQL compatibility or Amazon Aurora with Postgres compatibility. To what kind of compatibility? Oh, some error I got. The same thing for you?
Mm, as of now, no.
Okay, good, good.
Yeah, I got it. I think today Aurora it is giving some trouble.
This RDS, yeah, RDS some error is coming. So we go to this RDS, we click on this create database, right? So we can come here, we can just choose that Aurora, and then we can choose with MySQL compatibility, right? We can choose that provision.serverless, right? So we have no option here. You provision and manage the server instance sizes, you do it, or you specify the minimum and maximum amount of resources needed, right? If you choose this serverless, so you define the minimum and maximum only. Aurora will do the auto scaling thing based on the load of your database. So see this, how nice feature is this. Say like you don't know about your workload, sometimes many users will be there, thousands of users, sometimes no user may be there, right? So in such cases, right, you can go for serverless. So the name is serverless here. So it's not like there is no server, but it's completely hidden from you. You are not provisioning anything, right? You are simply saying how much resource you are needing, right? And then things will be taken care automatically. Aurora MySQL engine version earlier than this don't support that newest R6G generation instance classes. So you can just give some name, right? Database name you can give, correct? You want to do this? Try it out quickly.
It is not for free tier, right? It's for dev test template.
Yeah, correct. Here free tier option is not there, but we can choose that dev test thing. That's not an issue.
Mhm.
So we can remove the other one maybe. Meanwhile, let's remove the other one
Okay.
because again it will become
Chat.
extra only. Yeah.
Yeah.
So let's
Go
remove
first.
that RDS thing. This is the RDS, right? So let's go to this action. Go to delete.
Action.
Whenever you wish, you can just
Stop and delete or directly delete.
directly delete. If you stop, no, it will come up later.
Okay.
See, if you stop, it will see you can stop a database instance for up to 7 days only. If
Yeah.
you do not manually start your DB instance, no, it will automatically get started. So it's not like EC2. EC2, if you stop, no, it will never come back.
Yep.
It will never come up automatically. But this DB thing will come up after 7 days.
Yes.
So it will come for that minor upgrade, some kind of backup, some kind of maintenance, because DB is not to be stopped, right? Doesn't make any sense for DB to be stopped. So if you stop it, then automatically after 7 days it will come up, and then it will start patching, taking backup. All those things will happen automatically. So you just delete it. Now it says create final snapshot. Determines whether a final DB snapshot is created before the DB instance is deleted. So we don't want to create a snapshot.
Yes, correct.
So in production environment, it will make sense. Here it doesn't make sense. We will unnecessarily occupy our EBS volume and by creating that snapshot. So I acknowledge that upon instance deletion, automated backup, including system snapshot and point in time recovery will no longer be available. It's okay for me. I'm fine. Here I say type delete me. So we'll say delete me, right? It says we strongly recommend taking a final snapshot before instance deletion, since after your instance is deleted, automated backups will no longer be available to you, right? So for no production environment, for no practical sense, it's a good suggestion given by trusted advisor, right? So that you should take a backup. It's necessary, but here it's fine. We don't want click on delete, so it will stop and delete automatically.
I cannot delete option is not
Delete option is not there for you.
yeah.
Okay, what is going on?
Yeah, it came. Sorry.
Backup
In the
may
type
be happening.
delete me I have to mention.
Yeah, you
I
have to
just
mention
deleted.
delete space me also. Yeah, correct.
Yeah.
So now it's deleting. So meanwhile, we will click on that create database. Let it get deleted or no. Meanwhile, so we will come here. We'll just go to this create database.
I think, hello Harish. I think somehow I lost it because I just clicked it. The database is creating now, so it's under creation, Aurora DB. But I think you're saying about instance delete. I think the snaps are deleted. That was not asked me. It was not asking to me.
We deleted that database, whatever was there.
Oh, MySQL, right?
That MySQL was there, no, earlier.
Yeah, yeah.
Select that, go
You're
to
deleting.
this
Okay.
action, delete.
Okay,
And
okay.
yeah,
So why
type.
we're deleting? Because of this volume, right?
Yeah, correct. So it will be having that limitation, right? If you want to test again another instance or another thing, so RDS will be limited, right? 20
Yeah.
GB, 20 GB only, right? So you can delete it.
Okay, okay. Okay, I am doing that.
Yeah. So meanwhile, no, let me, it will be deleting. So meanwhile, we will go to that create database, right? And then we will have that option, standard create Amazon Aurora. Just look at the options that Aurora is giving us. MySQL, provision, serverless, right? So we have option for serverless, right? We have option for provision. See, correct? You're there? Some error
Yeah,
came for me.
for me, it didn't come any error. Uh,
Okay.
I don't know, it may come.
Yeah. So here what we will do is, no, for Aurora, right? Let's try one more time.
I think for me
Yes.
it says creating database.
Yes, we are getting this this Aurora, Dharma.
Yeah, yeah, I have submitted it. I chosen create database. So now it says creating database. My Aurora.
Good, good, good. I'm getting some error today.
Okay, basically we
Okay.
have to create and
Yeah, so mainly nothing like how we have done that RDS MySQL, right?
yeah.
So similarly, I'll explain you while one more time. Let me try. So I'll just give you the options. I'll just show you that dev test or something you're seeing, right? So here you just quickly come Aurora, compatibility, provision or serverless, whatever. Application feature, single master application is currently selected, right? So here you can say multi-master, right? So you have feature, you can have multi-master. There you were seeing that no, in MySQL, we have that single master, right? Here supports multiple writer instances connected to the same storage volume, right? Continuous writer availability is required. You may think of multi-master, multiple write requests, lot of write is happening. That's why this is fast. That's why this Aurora is so fast. DB cluster identifier name you give, some username, password, master password, instance size you choose, right? What kind of what class, include previous generation something. So you can choose what, say like memory optimized class, availability, durability. You want Aurora secondary master in different availability zone. Dharma, you are getting it?
Yeah,
Dharma?
yeah, yes, sir.
Yeah.
Yes, sir.
So
Yes.
you can, here you can just relate whatever we have learned there. You just relate. So you can have options, right, for whatever size, whatever availability zone, like how I was explaining you multi-AZ deployment, same RDS this is, right? So you have default VPC, you choose no public access, yes, no, maybe, right? Yes, no, only two choice only, no, maybe. Choose existing one security group or no new one, additional configuration, the port one, right? Exactly the same way how we do that RDS thing, and then you click on create database, it will create that database for you, right? So this is this is like Aurora thing. So you just try it out. You just find time when signals are good, just try it out, right? And let me know if you face any challenges with creating this Aurora also. So this is compatible with MySQL and Postgres. So that's the main thing about this Aurora. Next thing is like DynamoDB. Look at that DynamoDB. So what do you think? Those two things were no relational database we were looking. Now what is specific about DynamoDB? This is NoSQL, right?
Yeah.
So this is fast and flexible, right? This is NoSQL database service, right? And this is for any scale, big scale, internet scale, right? So key value and document database also they call it. Key value and document database. Very high performance, fully managed, multi-region, multi-master, right? How we saw that we can do that multi-master there with Aurora. Highly durable, inbuilt security, inbuilt backup and restore in memory. Caching option is also there, right? So this DynamoDB, as it is fully managed, right? So we have all those features here, right? It can replicate across multiple availability zones in multiple regions. This is something you have to focus upon. This is multi-region, right? So that is something, no, you just think of it. Getting it? Multi-region, I am telling, multi-region, not multi-availability zone. It is multi-region, right? So it's highly durable, right? Highly available, right? So it will provision the throughput based on the workload, whatever is the workload. Based on that, you will have all inbuilt, security, inbuilt backup, right? And in memory caching, right? So we'll be discussing on in memory caching. What happens, right? In memory caching, things, no, in RAM and all, it will be faster, right? If things are there in disk, it will be slower. But if it is everything is loaded in the RAM in the physical memory, how fast it will be accessed, right? So anything, any file or something you read, so that will come into physical memory, and then if you read it, then it will be very fast. So like that, it will have those features. It can, so they say it can handle 10 trillion requests in a day. 10 trillion requests in a day. This DynamoDB kind of database, right? 20 million requests per second, right? So up to that, no, that is the capacity. It can handle any peak, literally any peak load, right? On any level of service that is being available, right, over the internet, right? So many companies, Samsung, Capital One, Toyota, right? Many fast-growing companies are using this DynamoDB, right? For mission critical workloads, right? This is very much relevant, right? Say like kind of gaming apps, right? Or kind of Internet of Things, right? IoT, right? Some kind of internet-based huge applications. So this is giving us a great solution. DynamoDB. So where we can find DynamoDB? How we can find? Hello, Natras.
Yeah, we can search there, right? In the DynamoDB is already displaying.
Will it be there in RDS?
Yeah, no, not RDS. In the database list section, it is there, DynamoDB.
Okay, good, good.
This is not, I think this is not RDS. This is NoSQL, right? So it will not come under RDS, I suppose.
That's right. So simply we can say DynamoDB. We can find it here. So this is managed NoSQL database. Amazon DynamoDB is a fast and flexible NoSQL database service for all applications that need consistent single-digit millisecond latency. Single-digit millisecond latency at any scale, right? See, for mobile, for web gaming, for ad tech, for IoT, for many other applications, make it a great option. So here, what we are going to do, create table. Are we creating instance or database here? No, right? Understood?
Yeah.
So here we are not creating any instance, we are not creating any database, we are not doing, we are creating table. Simply we are creating table, you see. Right? So it says create a DynamoDB table. Right? So you just give name of the table, Dynamo table, right? And just give some name, Dynamo table, and then some primary key it is looking for, right? So we can give some primary key, some, we'll say some user ID, right? Then we can say some number as a user ID, that primary key. We have some option like adding sort key. You can also add some sort key by what you want to sort it. You can skip it as well, right? So we can mention some primary key here, right? Some kind of partition key, right? Table settings. Default settings provide the latest way to get started with your table. You can modify these default settings now or after your table has been created. So we can use default settings. So if we use default setting, then we just have to click on create, nothing else. If we don't want that, we remove that, then it will ask for secondary indexes, right? Read write capacity mode, provisioned capacity, auto scaling, right? Encryption, all those features are available now for us to choose, right? So here you see provisioned capacity, read write capacity, provisioned, on demand. What is on demand and what is provisioned? Just look at it and just change and see. This provisioned, here it says free tier eligible, right? So this also free tier eligible, but that will be provisioned, something, no? Capacity, read capacity 5, write capacity 5. Here if you say on demand, not applicable because read write capacity mode is on demand, right? So whatever is on demand, like whatever is the load, based on that only it will be, no, capacity will be applicable. So auto scaling not applicable because read write capacity mode is on demand. For on demand, you don't have to do any kind of provisioning. So when it is on demand, encryption at rest, default KMS encryption or KMS AWS managed, no, CMK. So if you just keep it default, this is by, no, key is owned by DynamoDB. You are not charged anything for this. For remaining things, you will be charged accordingly, right? So customer, what kind of key you are using in the key management system, you are putting that key. Based on that only you are doing the encryption of your data at rest. When the data is kept in the table, that time how you are encrypting it. So just something basics here, and then no, you can click on that create. So here if you go to this provisioned one, you see here the provisioned one, you see read capacity, write capacity 5 unit, 5 unit, like that. Read capacity, write capacity 70%, 70%, 5 units, like that. You see some options right there.
Yes.
Right. So what will happen here, say like there will be some kind of, no, write capacity unit and read capacity unit, right? So it won't be kind of, no, one request or something. So say like you have some one API call will happen to the database, right? So one API call to DB for reading data, right? That would be read request. One API call to the database for writing data will be one write request, right? So read request and write request. So there will be certain, say like standard, right? So say like there is some like some kind of some size of some item, right? Less than that, if it is, that will count as one read capacity unit. If write request for a particular size is there or less than that, it will be called as one write capacity unit, RCU or WCU, like that. So based on that, they will decide how many, read capacity, how many write capacity, how many requests are going for writing, how many requests are going to the database for reading. So based on that, there will be some kind of cost involved with that, right? So that is what this is. Or you simply choose on demand, then it will be like based on the demand, whatever request or something. So based on that, it will happen. So you can simply say create. Right, it says requested resource not found, table DynamoDB Jan not found service. This something, some error has come. Right, so table is being created. Now it is there. That time it was not there. Now it got created immediately. Correct? How soon it was?
Very quick.
It was very quick, right? Done. That's it. We are good. With one click, right? Our table is created. We don't have to do all the database and instance and all this. So this table is done. We have items, metrics, alarms, all those things, right? So how it is like how you can come back here? Just now say like we're here. One table is created. You can create multiple tables here. Create table, create table. Now just close this. Just go back to AWS, right? Just go to that DynamoDB. When you go to DynamoDB this time, so it will be in different shape. So now it will show you total capacity in this Asia Pacific, this in. So just go to this table, you'll see your table there. Correct now? You just select your table, right? So it will show you the features here. So you have overview, you have items. Go to items. Here in these items, right? Now let me close this. Just go this way. Just see here, right? So you have some item option, create item. Just click on create item. You see this UID number. It's asking for some value. You can give some value, right? You say click on plus. You have option to append, insert, remove. Say append your number, string, or what? Getting it? You say number.
Yeah.
Number. And you say number 2. Again, you see in place of that UID, right? So you say like here you just say UID, then it says enter an attribute value. You say here 2, then it takes. You see? Correct, no? You see here, you want to insert something here, insert a string. You can insert some string value also. Correct? So you just say like name, right? You say something ABC. See, like this also is happening. Name is coming up like that. You simply say some pen, you just say like some string, you say some city, and you just say like Bangalore. So that is happening. Correct? So like this, you can whatever you wish, based on that you can just make entry here. Just you want to remove, simply you just click on this will be removed. Correct? Name, UID, city. Just click on save. You have like 1 Bangalore ABC. Found it? Getting it?
Yeah.
So you're just things are not very much strict here, right? It's not like very much row and column format. You found that, right? Whenever how we have made the entry in the same table. So key value and document database this is, right? So you can create something and then you can just try to search for some data. You can try to take some action, manage CTL, manage live count, lot of features are there. So just you can just try to explore this as well, right? You want to delete this table, so you'll have option for that. Just here, right? You have option here, delete table. Simply you click delete all CloudWatch alarms. Also create a backup before deleting. No, don't want. Simply type delete. Right, you delete the table. Simply it will get deleted. Right. Simple. That's it. Now you want to create table. You just click on it. Give some name. Right. Test. Right. This is something important. You can just give some name and click on create. It will get created. So as simple as that. So here I just wanted to tell that it is a fully managed, right? NoSQL database service that provides fast and predictable performance with seamless scalability, right? It allows you to create a database table that can store and retrieve any amount of data and serve at any level of request traffic. Correct? So just see this DynamoDB and then
So this one, Harish, I have a small question here.
tell me, yeah.
Suppose if you want to use DynamoDB for some application, right? So from application, if you want to connect this, right? So see, like how we connected this from SQL Workbench, right? We connected this SQL database, MySQL database through Workbench. So like that, for example, if you want to use this DynamoDB for some application, so we have to do the database connectivity and all those stuff. So this one, how to see?
There is
This
nothing like database
directly,
connectivity, nothing like
directly this is
directly.
directly table name. So how I can refer this direct name which without any at least server name, nothing there, no instance, nothing there, only table is there. So how to connect from application to this one?
So simply you can start referencing by table name. You will be writing your SQL query, right? And your document can directly start using this. Say like when you created that table, right? So you just gave some
Yeah,
table name, right? So some
yeah,
this
because
table,
when
some
DynamoDB right is just directly get into table creation. There is no database name, there is no instance name, nothing.
correct. So it
So
is
if you refer this table from, for example, some application like Java or something like HTML scripting, right? If you want to uh, uh, load the
correct.
data from there to here, right? So we have to refer this at least, right? So just simply referring table name, right?
Correct. Simply how no that see like by just by referring to the table name, how it gets created. I'll just show you, right? So as soon as it gets created, it will tell you the endpoint. I'll just it will take a while. Let me create one more time. See, it's created, right? So you just see here, right? Table details. So you have the option here in the table detail, you have ARN, right? So
Okay,
using
okay,
this ARN, right, it will be like test name I have given, right? So using that ARN, you can reference this table anywhere as a resource, right? And then you can reach out to this, right? Based on that ARN itself. You just mention that, and from that ARN, right, you can just refer to it when you add some item or whatever, but that will be added in this test, correct? So
okay. So ARN is the name for connecting to this database.
correct, using that you can anyways you can connect, right? And then you can create some global table here, right? So
Mm,
to create a global table, ensure that DynamoDB streams are enabled. So you will have this enabled. You can use some, give some role and all. So you can globally access that wherever you wish. But this is like just by this name, this just by this test
yeah.
name, you can refer to this, and it will be like if you want to use anywhere, this will be completely unique thing across, right? Amazon, right? So you can simply mention this, right? And you can refer to this. You can integrate this with any application, right? You can go to the policy. You can give that option here, right?
Okay, yeah.
Yeah, and see, you can create clusters, right? So a lot of other features will be there, right? Preferences you can have for the table and all, right? Backup and all you can keep. Dashboard will show you like whatever alerts or something is coming. So mainly it's like non-relational database. That is what is the most important thing here, right? So here you just don't have to mention that
Mm,
the entire detail and all. Simply it will be accessible to you, and simply you just addition of item and all those things will be also easy here. You can just control that, mention that access control thing. You can attach that policy here through the IAM, how we were creating that role, right? So there can be some role through which it can be associated, right? So a lot of such features are there. You have option Web Identity Federation allows you to log into this. So that no third-party tools and all for authentication also can be integrated here. So you can sometimes you try to log into some website or something, it will say login with Amazon, login with Google, like that they will tell, right? So those kind of features will also be there. Identity Federation. So that also, those kind of feature. Either you use that IAM thing, or you use some kind of web identity federation. Also login with this, that all those things can also be associated. So a lot of features are there. You just try to explore further. So let me know if you find any challenges. Okay. So here you will have FAQ also. So in FAQ section you go. So you will just find what is DynamoDB, right? What does DynamoDB manage on my behalf? What is consistency model of DynamoDB, right? What kind of query functionality does DynamoDB support, right? So just go through all these things and then let me know to find how do I update any query data items with DynamoDB?
There
Can
is
DynamoDB be used
yeah,
by
yeah.
application running? So all these
Well, there
things
is
you just go
no
through.
security, nothing you have chosen. It's all taken care by them by default.
Everything by them only. Yeah.
Uh,
Right. So you just go through all this link, right?
Suppose if you access this using this ARN name, right? Will it be accessible the table? I don't think so from browser, right? I don't think so.
Through application you can access it, not from that normally, but through application you can access and use it.
Maybe some drivers should be installed to access this DynamoDB, right? So
Yeah, this is based on that get and put request only. You see, it supports get and put request, right? So, but how you are accessing it, you are just, it's kind of just one key, your partition key you are putting. That time we were putting that UID, right? So that's it, one user ID something we were putting, and based on that allow you to quickly read and write data on the items associated with the given user ID. So based on some user ID, right, you just you can access it, you can just start using it. So how do I update and query data items, right? So after you have created a table using this, you can use put item, right, or batch write item APIs. So this is what you require, that APIs you require, right, to access it, to query it, right? There should be some query API, right, through which you can use to retrieve your data from your table. So manually we are creating it, like how manually we are accessing it, right? Manually we can through browser, means through console we are going, right? So through console we are going, and through console we are doing, or through CLI you can access. Command line interface we had seen, right? So through CLI we can try to query it. Through SDK we can try to query it, right? So lot of parameter would be there, right, to access it through the query. So like this you just need some syntax, right, to write some query, right? So that will be too much in-depth thing. So just want to explore, you can just try to explore, but the people who are using this document DB and key value pair, so they can easily do this, right? So response elements, items, list evaluated key, some kind of error handling, right? Say like retrieve a range of items. The following example queries the reply table for replies in a forum that were posted by particular user. Local secondary index on the reply table, right, to facilitate like this. So sample, some requests will be written like this. Accept this, content this, user agent, content type, authorization, how you are going to do that authorization, right? What kind of credential you are supplying, right? So based on that, so some response will be given automatically, counting an item, sample response through CLI.NET SDK, C++ SDK, right? For Go programming, that SDK, for Java, for all those Python, Ruby, right? So a lot of SDKs are available here, right? So through which you can just try to integrate things and try to query things. All will be available. Directly you can access that table. But the only thing is you require some, some kind of writing that query, SQL query. Okay, so for now, what we will do, I'll just delete it. Anyways, it is not harming, but I'm just doing some cleanup. So I'll just remove it for now, right? Just come back here and look at the next, the concept of warehouse. You heard about data warehouse, right?
Yeah, collection of all the databases.
Yeah, so that is like kind of data management system, right? For business intelligence.
Informatica, I think IBM, Cognos, right? I
Yep.
think these two they use for this data warehousing purpose mainly. ETL.
Big data analytics, right? Web analytics kind of thing, right? Some speech analytics, some that Google analytics, right?
Yeah.
So those kind of things, no, we also do, right? So kind of, no, especially for analytics, no, they're using it, right? Data management system. So there is difference, huge difference between no, the traditional one and this one. The traditional data warehouse will be there, right? So apart from that, as confirmed, compared to that one, right, we'll have a lot of more features here in this Amazon provided, data warehouse. So mainly like, it's for data warehouse will be using for what? For managing the data management system only, right?
Yep.
So kind of some business intelligence nowadays they require some kind of, they want to analyze the large amount of some historical data, right? So they want to know where the data is coming from, right? Right, exactly, right? So they can take the data from many sources, right? And then what they will do, they will keep it there, right? And then they will do the analysis. Say like usually say like some applications are running, right? Application will have some log files, right? Log files will have some database, some data, some kind of information may be coming from whatever MySQL database that we were running in our RDS. Some kind of information might be kept in some other relational or NoSQL database. So from lot of sources, right? So data would be, the historical data would be coming, right? Some client applications you see for JDBC or DBC something. So now there will be some leader nodes, so it will be taking all those data. Then those data will be coming to the node, compute node 1, 2, 3, 4 like that. So multiple those nodes will be coming, and there will be cluster of those nodes, and then there will be storage behind, and then they all will be working together, right? It will be centralizing, consolidating, right, the data that are coming from various sources, right? It will just keep it there, right? And then it can analyze it. It can analyze. So historical data analysis. So informed decision making based on consolidated data from different sources. It will do the analysis of the historical data, data quality, consistency, accuracy. It will take care of, and then it will check everything whether it is consistent or accurate. Then separation of analytics processing from transactional database improves performance of both systems. So if you just don't use that transactional database, some kind of relational database that is running, so whatever analytics processing if you do directly in your database, right, so that will slow down your original database. If you take the data and keep it here, and if you just do the computation here on the data, so your traditional whatever transactional database is running, so that will not have the burden of doing the performance analysis. So here it will just come to that part, this warehouse cluster part, and this will do the computation, right? So that there won't be load on your transactional database. Here it will handle the load, so that will be free, that will have no burden. And here also you will not have much burden. Getting it? Understanding the difference?
Yeah.
So what is the main purpose? Who is using it? See, if some lot of competition is there in the business, right? So the companies will be competing with each other. They will try to understand what is going on, right? So who is doing what, right? How much is the customer base, right? Whether I should invest my money in this particular business or not. If I invest, then what will happen? If they don't do all those analysis, and if they put a huge amount in the business, then they may be in loss later. So just by taking all this data and then analyzing those data, right, they are trying to understand the behavior of the customer, right? And they are trying to stay competitive in business nowadays. Lot of competition, right? So this becomes so much relevant now, right? Because of all those things, right? So you are going to a website, Natras, and for how long you are staying on that website, which links you are clicking,
Yeah.
right? And how long you are connecting and disconnecting, how many pages you are browsing in one particular session, right?
Yeah.
Everything will be recorded.
Yes.
So complete website traffic, right, is, say, like you are going to Amazon.com and then you are trying to look for some particular thing, and then you are not buying and closing that Amazon.com website, then Amazon will just go and check. Nataraj had logged in. He spent some 15 minutes. He tried to look for some particular thing, right? But finally he didn't buy, right? And he has quit that application only. What might have happened? Why did he not purchase? What was he browsing, and why finally where did he go? So all those things it will try to analyze, so that next time when Natras comes, it will try to give a different experience, right? So that next time Natras will obviously buy. He will be very happy, right? Because whatever issue, whatever he could not find last time, now it is available, right? So now this time he will definitely buy. So he is the website is analyzing, doing all those analysis just to make sure that who are the potential buyers, they become the actual buyer. Like that, they are doing, lot of things are happening in the business nowadays. So this Redshift, right? This is the data warehouse provided by Amazon. Redshift, Amazon Redshift. So very fast, right? Very cost effective, very simple, right? 10 times better performance than any other data warehouse, right? 10 times better performance they claim. So they say this is very fast, cost effective and simple, right? So it will be using some machine learning. You heard about machine learning, Dharma? Machine learning. Dharma, you're still there?
Yeah, machine learning, right? Yeah, Python machine learning.
Yes. So that machine learning, here, this Redshift is using that machine learning, right?
Okay.
Now there will be parallel architecture, right? Very massive scale parallel architecture will be there, right? The hardware will be compute optimized, right? And we will have some kind of result set caching. Result set caching means, right, whatever results are coming now, that will be cached. So just understand, like, you will have some kind of query, some query will come, then that will give some results, right? So you looked for some information, now it has given some results. So those results are cached, right, in the memory. Now, next time that query doesn't have to come to particular that database. It will simply be answered from the memory. So whatever query was made, right? So now that query will be taken directly from here. It will go from the result set. So there is a concept of result set caching. Result set caching. So high throughput, no, and latency will be very low, right? Response will be very, very, very fast, right? So whatever information is required, it will quickly come from the result set, from the memory. So good features it is having, right? So it's simple as we see, right? So it's simple, like simple, right? Fast and cost effective as well, right? So it can start with, you can say it can start with $0.25 per hour. Okay, 25 cents. Fine.
Yeah.
Per hour, 25 cents. Right. Now it can scale up to, right, dollar some 1,000 per terabyte per year. Okay, cheaper. Okay, so if we look at the monthly cost prediction, right, we go to that billing section, right, and we can go and do that prediction, right, in the billing section, right. In that we go and we check there, right. So we find that, okay, now it is like, how much we should use, right, how much is available, how much we have been using. So all those analysis we can do, right? So we want uh, to get the performance, right? Say like for kind of any kind of interactive analysis, right, or any kind of reporting, right? So based on the whatever data we are collecting, based on that you want to share some reports, right, to the leadership, to kind of business unit, right? So what we can do, we can create that query and we can create those very complex queries and we get the result set that will be available, right? Again, if we require it, it will be available in the memory. It can be quickly taken from the memory. So it will be very fast, cost effective and simple. Okay, look at the other concept, elastic cache. Elastic cache. So what is elastic cache? This is again in-memory cache. So when talking about in-memory cache, right? So this is fully managed. This is open source compatible in-memory cache, right? And say like you have a relational database. Okay. Now you have a query which is running very slow. Okay. You have tried all efforts by fine-tuning your query, by doing some kind of maybe indexing, right? So it might be, have you ever faced such a situation, Dharma? Hello?
Yeah, yes, Harish.
Sometimes your database, your query becomes very slow.
Yeah.
So you do some kind of tuning, some kind of indexing, right?
Yeah, yes.
So a lot of things you do, and just think in case it doesn't fix the issue. So what happens? There can be some kind of data, right? Depends on data also. What kind of data, right? So what kind of data? Maybe because of very huge files, very huge pictures, very huge videos, something, some kind of data. What kind of use data is there? We don't know. So whether we do indexing or whether we do kind of tuning, it may not work. So what is the solution? The solution is create a result set. You have the database, right? Now this database, right, you are running some query, right, getting the result, right, and storing that result where? In memory. Okay, you are storing that result set in memory. You are there with me, Nataras?
Yes, Harish. Yeah, I can hear you.
Yes, yes, yeah.
So you are storing it in RAM. You are storing it in memory. So which one is fast, RAM or hard disk?
RAM.
Now that is physical memory, that is fast. Here your database, the data is stored in disk, right, storage, right? So from there, very complex query you have run, and then you have got a result set there, and which you are storing in the RAM, in the memory. Say like we have hundreds of applications or hundreds of, say like, web services looking for this particular result. Hundreds of applications are there, right? And they are looking for the same result set. 100 times it will go to database, and 100 applications will connect and disconnect, and they will mess up your database, right?
Yes.
What will be the fate of your database? Definitely it will be, query will be slow. Correct? So instead of doing all those, simply the query is run only once. Now, whatever data is there, that is stored as a result set. Let the application access the result set directly from the physical memory, right? How fast it can be, right? Just imagine. Just imagine. So this is what is Elasticache.
This is similar like a buffer, right? So in the database buffer.
Yes.
So when you run, when we run the query first time, right, it will get from the database first time. But if you run the same query repeatedly again and again, the query is same. It will look for the results in the buffer. If it is there, it will fetch and retrieve it. Otherwise, it will go to the database. So I think the same concept.
Yes. Same concept. That concept only they have put it here. So say like you have your relational database here, right? You have your relational database here, right? So on top of it, they will put this Elasticache in front of it. Okay. Now this will be accessed by the applications. So whatever things are there, that will be cached here in the front. So what will happen? Whether it is NoSQL database, right? Let it be relational database, or let it be NoSQL database, or let it be S3, right? Let that be S3. Doesn't matter. Let that be anything. On top of it, in front of it, you put this Elasticache. Apart from this, right? You have Redshift warehouse we were looking at, right? So just think of the architecture for that Redshift warehouse, whatever things are coming. Now you have that Redshift warehouse, right? In front of that, you put this Elastic Cache, right? Now, what will happen? Faster access, right? Can be accessed faster because all those results are there. This is no, the only thing is this is physical thing. This is no, just physical memory. So it's not like it will go and ask and search and do this and that. So a lot of those issues are not there. So whatever frequently accessed, right? Frequently accessed data, so that will be kept there, right? It will be useful. Whatever is the workload here, right? That load will reduce, correct? That load will decrease because this particular thing, say like your Oracle database or something is running here. So if you just let all applications connect here to this relational database, it will be slow. It will become slower. Next, in place of accessing that database directly, you put that elastic cache, right? So elastic cache. So because of that, what will happen? All the applications will be accessing it, right? For all the frequently thing will come here. And as you told, if something is not there in that, so it will just run the query here once, and again it will be cached here, right? So what will the use case? DB query caching, right?
Mm.
Correct.
Yeah.
So kind of you have a website, right? So complete website can be cached, right? A particular session is there, that session can be cached, that whatever related to that website, entire website can be cached, and directly if you can access it next time, it will be very quick, right? So those are the situations where we will be using that elastic cache. So next thing is like SNS. SNS, is it familiar?
CloudWatch notification.
Yeah.
Yeah.
So remember last time, we were doing that, right? So that notification thing. So what did we do, right? This is like we had that email you had received.
Yes. I think yes.
Okay, good. So managed messaging service decouples publishers from subscribers, system to system messaging for microservices, distributed architectures, serverless applications, right? So publisher, Amazon SNS, and then the subscriber. So usually there will be relation of publisher and subscriber. So there will be some publisher and there will be some subscriber. Subscriber will subscribe to the facility that is given by publisher. So like that, they are giving some term publisher and subscriber, right? So we just go to that SNS, right? Say like we go to this SNS from here directly. You just look for SNS, simple notification service, SNS managed message topic for publisher subscriber, right? So you just go there. You just see here some 4 topics I'm having. So application to application. Amazon SNS is a managed messaging service that lets you decouple publisher from subscriber. So decoupling means what? You heard decoupling? Many people you might have heard that people will say, okay, this is cloud will have a lot of decoupling, right? So lot of decoupled architecture. So some kind of physical structure which is not tightly integrated with the other component. So one component, right, will not be depending on the other component, right? So say like cloud provider is managing that RDS, you are managing your table, correct? So you are just simply creating table but that is the RDS is managed by the AWS. So some similar to that, where no some kind of difference is there in the way we are creating a structure. So there is a gap. There is a gap. So you might have heard about loose coupling. So you in the train you see how different compartments are connected loosely. You have one compartment and then there will be another compartment and then another compartment. There will be one connection, right?
Yes, yes.
So here there will be one connection, right? So if something happens, say like in the train, sometimes something happens, so two compartments might fall down. This might get disconnected, and remaining compartments might not no get part of the accident. It happens many
Mhm.
times. No, two compartments only derailed,
Yes.
remaining saved somehow. So something like that happens. So there is benefit of that loose coupling, right?
Uh-huh.
So that is kind of loose coupling. So what will happen if it is tightly? No, everything is connected together very tightly, right? So lot of challenges will be there, right? If it falls, everything will fall together. So like that only the applications, right? The underlying structure or two different applications or something like that. If they are not directly connected, right? If they are directly connected, all will fail together only. Now, if it is not directly connected, so all will not fail together, right? So that's why we call it loosely coupled or decoupled, right? Those kind of terms are there. Okay. So here they are they are doing some kind of application to application decoupling. Applications are not directly connected. There is like kind of SNS. Through that they will connect to the other subscribers, right? So Amazon SNS is a managed messaging service that lets you decouple publishers from subscribers. This is useful for application to application messaging or microservices distributed systems and serverless applications. So here you have publisher, you have SNS, topic, Lambda, SQS, some SQS also we will be looking at. So this is another decoupling mechanism. Application to person. So there is application to application, this is application to person. So what that email you received, right? So that was application to person. You are subscriber there. You had given your email address, right? Dharma? Dharma, are you still
Yeah,
there?
yes, sir.
Yeah.
Yes, sir.
So
Yes, sir.
Amazon SNS lets you send push notifications to mobile applications, text messages to mobile phone numbers, plain text emails to email addresses, right? So like this, you have the publisher send messages from distributed systems, microservices, and other AWS services. Now SNS, right? It will have some SNS topic, right? And then topics decouple messages publishers from subscribers. Now here the push notification will go, text message will go, email will go, right? So you are the subscriber, can include mobile apps, mobile phone numbers, and email addresses. So these things, your things will be that subscriber here. So like that SNS, you go to this topic. So some SNS topic is there, auto something, cloud trail for some my topic, where get some SNS topic we had created recently. So this is there some kind of topic owner, some kind of pending confirmation is there because this was not never confirmed, right? For you check, so you can create some kind of subscription, right? You can just mention what you want to use, which protocol you want to use for what topic. So you can just mention some policies and all. So this you just understand that, go to topic, go to create topic. So we'll have some different type of options, FIFO and standard. First in, first out, strictly preserved message ordering, exactly once message delivery, high throughput up to 300 publishers per second, subscription protocol SQS, standard, best effort message ordering only, at least once message delivery, highest throughput in publishers per second. Subscription protocol will be no SQS or Lambda or HTTP or SMS or email or all those things, right? So you have the no different choices. You just give the name of that topic. You just give some display name, whether you want some encryption, some kind of access policy, right? What kind of policy for that delivery retry, right? So you just give all those things. You just do that. No, give some tag, status logging, right? You want to make it HTTP or some kind of Lambda or SQS. So SQS and Lambda will be looking at, right? So some kind of role you have to integrate, right? So it will require some kind of permission. If you want SMS, no, this SNS requires permission to write logs to CloudWatch logs. You can use separate roles for successful and failed message deliveries. So you can create no new service role or some kind of existing service role also you can use. Right? So based on all those things, this is no this SNS thing, right? And there is another thing that is called what? SQS. So just look at this SQS, right? Queuing service, have you heard? Hello.
No, sir.
MQ,
No.
something you heard?
A queue we know, but a queue service I haven't heard.
Active MQ, MS MQ, some kind of things you have been hearing, right?
Message queue, right?
Message queue only, MQ.
Yeah, I think that's there are some tools from IBM. Yeah.
Yeah, so like that. Active MQ, some open source. Application people will know this better.
I think it will transfer the message from one application to another. I mean, one system to another system, or one application, one tool to another tool, like that.
Yes, correct.
It makes
So
connectivity and also receive the file and post the file to the appropriate destination, and also receive. Yeah, it's actually kind of a middleware.
yep. That is like from one message, from one application to another application, right? You want to send some kind of no message. Understood? So you don't tightly integrate both the applications, right? You just send, say like, it's kind of, just understand again. So from this one application is there, and then there is another application. So this application may require some data, some input or something. So now there is a pipeline, right? So some message will be sent here, and now that will be consumed by this consumer. This now, if it is not consumed, those messages will be here. So whenever, say like after 5 minutes or 10 minutes or 20 minutes, if this particular app wants to use that, so it will take that, it will read it, and it will consume it. Now after some time, it will consume the other one also. It will consume the other one also. So it will consume other. Now if you have different pipelines to one more pipeline, so another message will also come here. That will be kept in the queue. So again, that will be consumed here. So here it will be sending the message and it will be consuming that message, right, as and when it is needed. Just think, kind of how we are looking like emails are coming. Somebody is sending that email, it is just kept there. Whenever you wish, that time only you go and check your email, right? Correct? So you are the consumer, right?
Yeah.
Yes.
So you consume it, whatever things are coming based on your need, you are consuming it. So like that only here, it can be application to application, not like application to people, from one application to another application, right? So the different parts of the same architecture, right? Maybe different applications, right? And now based on it will be asynchronous, not like simultaneous. It's not like as soon as I call you, that time only you have to pick my phone. I will send you SMS whenever you wish, that time you check it, right? Whenever I just send you some message, WhatsApp, you just check it. So like that, whenever you wish, you can just consume it, right? Up to you. There will be one message queue, right? And it will be providing you kind of buffer, right? Some kind of storage. So there, all those messages will be kept, right? And then temporarily it will be there. Sometimes there will be issue. If a lot of messages are kept there and then messages queue get stuck, right? So that is something you have to troubleshoot, right? But from one endpoint to another endpoint, it will be going. All the messages will be stored there, and this will be consumer. This will be producer, right? One will be producer, right? Another will be consumer. So one will, and there will be some queue, right? So like that it will happen, right? So these two things are related. Again, this is related to decoupling. So it won't be like tightly integrated. It will be like applications will be decoupled. So it says fully managed message queuing service, decouple and scale, microservices, distributed systems, serverless applications, right? You can do decoupling, send, store, receive messages between software components, right? Two types of message queues. Standard queues offer maximum throughput, best effort ordering, and at least once delivery. SQS FIFO queues are there, right? So that will be messages are processed exactly once in the exact order they are sent. First in, first out, those kind of things, right? So that is SQS, simple queue service. The previous one was simple notification service. This is for simple queue service, kind of middleware thing, how you told, right? So what will be the benefit? The benefit will be the security also, right? So say like instead of combining two things directly, right? So you just send the message, right? And that message can be encrypted, right? And you are sending that, and then the other component is using it, right? Based on the requirement, right? So both are not indicated. One is compromised, another will also be compromised. So that will not happen, right? So data will be protected. Data will be the main database, main data will be protected only. So that will go to another one, and then it will be used based on the requirement, right? So sir wants to use that application, somebody will be using this application, so like that. So a lot of things are there related to that, and then it will be scalable as well, reliable as well, right? So a lot of features are there apart from that, right? So kind of MQ, SQS, right? And SNS. So those things you just try to get more theoretical concepts, right? Practically doing it will be based on the application requirement, right? So apart from that, we have a concept called Lambda. You heard Lambda anywhere, anytime?
No. I was about to ask this question because in the previous slide I can see lambda, so I was about to
In
ask, but
maths
anyway,
class, we
we
heard
covered it.
when we were in school.
Where did you hear about it?
In the
Madras?
maths class, schooling.
Good. Same symbol we will be using here then.
Yeah.
Lambda, right? Okay, yeah. So
No, I think in the previous slide also you have put lambda.
yeah, this is the one, right?
Mm.
Right, lambda, yeah, correct. Yeah, somewhere I think I have put that picture. Yeah,
I think
see here.
go back. I think 171. Slide number 171. AWS lambda. Go next slide. 172. Sorry, 172.
Yes, correct. So as a subscriber, as a consumer, yes. So see how this SNS, right, and how this can be the subscriber or the consumer, right? So that we can see in this lambda. So this is really very interesting, this lambda actually. So serverless computing, right? Write code. So serverless, whenever we talk about serverless, right? So what do you understand? There is no server?
Server will be there.
Yes, but we cannot see it, correct?
Yeah.
So it will be all internal, right? Completely managed, fully managed by AWS, right? So there nothing will be visible to you, only some kind of function, right? Whatever functionality you use, just focus on that. That's it. So that is called serverless computing. Simply do whatever you want. That's it. Doesn't want to go and get into detail of how to go to the system and how to do something. Simply you just write your function and run it. That's it. So you write your code, upload to Lambda. Simply you write your code and upload to Lambda. So serverless, write your code, upload to Lambda, pay only for consumed compute time. So that CPU, memory, everything will be there, but you will not see it. Simply, it will be very fast and you run it for 5 minutes, right? For 2 minutes, for 1 minute. You want to do something, just do that activity based on your script, based on the code that you have mentioned. It will happen simply like a magic, and it will finish quickly. It will come, it will run, it will go, right? And activity will be done. Consistent performance will be there. Code is run automatically. Application is scaled automatically by running code in response to a trigger. So you trigger something and it will happen. Charged per 100 millisecond of code execution and per trigger basis. So you will only be charged for those 100 millisecond multiple of that 100 milliseconds. You are running for say like 1 minute, you will be charged only for 1 minute. You are running for 30 seconds, you will be charged only for 30 seconds. So you don't have to run the EC2 instance for 750 hours, right? Simply you achieve what you want to achieve. That's it. Now you just take a look at this picture. Upload your code to AWS Lambda to write code in Lambda's code editor. Set up your code to trigger from other AWS services, HTTP endpoints, or in-app activity. AWS Lambda, it will go to Lambda runs your code only when triggered, using only the compute resources needed, right? Whatever RAM is needed, whatever CPU is needed, it will take that much. Just pay for the compute time. Just for those 30 seconds you pay. Don't have to pay for long. Let's take one example here. You take a photograph, right? And now photo you upload to S3 bucket. Okay. Now Lambda is triggered. So you can just say whenever a photo is uploaded in my S3 bucket, bucket, you have bucket, right? So in that bucket, you simply mention that as soon as any photo is uploaded here in this bucket, anything is uploaded here in my bucket. Now let the Lambda get triggered, right? Lambda runs image resizing code. As soon as Lambda runs, it will run one code that was written. So it will run some image resizing code. Now photo is resized into web file or tablet sizes, 3 sizes, right? So simply what you have to do, you just have to take a photo, right? And upload to S3. That's it. Then what will happen? 3 different size photos will be created and kept properly there. Understood?
Yep.
Very interesting. So some kind of hello world, some kind of hands-on we will do. This will be interesting. So let's go to this. Let's go to this AWS console.
Okay. Yeah.
There you look for Lambda. Run code without thinking about servers. Lambda.
Create function, right?
Yeah. So I had created earlier some hello one or some function. So we can create some function. I'll just delete that. Okay, so I have no function, right? So we just come here, we give some name, right? So give some name, say like hello again, hello, right? Give some name as hello. Dharma, you're there?
Yeah, yes, sir.
Yeah, give some name, hello hyphen Jan, some identifier you give, some function name you give. Okay, click on create that create function. What happened? Sorry, I just gave name there. I think after creation, then we should give the name, right? So just click on that create function, right? As of now, no function, right? No function. So click on create function. Now author from scratch. Start with a simple hello world example, right? So this is what I do usually, to begin with this small thing. So basic information, function name, you give some hello, right? Hello team, something. Now here you come to this runtime and choose the language to use to write your function. You see what all options are there.
Python, Ruby, Java, .NET.
Correct, no?
Yeah.
So whatever you know, right, that you can choose simply, right? Whatever you know, whatever code in whatever language you want to do the coding, you choose it, correct? And then you write something and then it will be run, you just configure it. So say like, for example, I choose Python. Okay. Now look at the permission. By default, Lambda will create an execution role with permission to upload logs to CloudWatch logs. You can customize this default role later when adding triggers. Change default execution role. You see the options: create a new role with basic Lambda permission, use an existing role, create a new role from AWS policy templates, right? So a lot of features are there. Correct? So let's create a new role with basic Lambda permission as well. So let that get created. Lambda will create an execution role named hello-team-role something with permission to upload logs to Amazon CloudWatch logs. So it will upload the logs to CloudWatch logs. Now go to advanced settings. Just see here, code signing, then network. Two options are there. Right?
Yeah.
So to enable code signing, choose a configuration that defines the signature validation policy and all. So just forget it. Network, to provide network access for your Lambda function, specify a VPC, VPC subnet, VPC security group. VPC configuration is optional unless your user permission required you to configure a VPC. Right? So this is again optional, right? If you want the network access for your function. So do you require network access for a function? You can choose that default VPC or something. So if you choose that, then it will ask you for subnet, then security group, then all those rules and regulations and everything, right? So we are not in this, we are not doing anything. So we are not using any, VPC, but just understand that, what we want to do, why it is needed. When we choose this VPC, right? So we can select the subnet, we can select the security group, we can give some permission, then that role, whatever we are creating, right? So that will have option to use all this network feature and subnet and the internet gateway attached and all those things to access the network, right? To go out to S3, go out to somewhere, right? So all those things will be there depending on this VPC feature. Okay. Now simply you click on create function. Tell me once you are done.
Still it is creating. Yeah, configuration. Yes, I got it.
Dharma?
Yeah, it's going on. Just give a second. Yeah, I think it's created.
Perfect. Perfect. So now you just see here, you have no see the designer thing here. So in designer, it will show you hello team, layers, right? Here some add trigger, add destination like that. So just like this, you can just make this designer open and close, right? So let that be closed, right? So here you see under this configuration, right? Here you see the function code. Look at the function code, right? So import JSON, definition, lambda, handler, event, right? Return status code 200, body, JSON, hello from lambda. You see this message?
Yeah.
So this is your lambda function, right? So if you just try to test it, you have here test option, right?
Yeah.
You just try to test it, right? What will happen? Just try. What does it say?
Configure
Configure
test event.
test event, right? Configure test event. So we have to configure some event, right? So a function can have up to 10 test events. The events are persisted, so you can switch to another computer or web browser and test your function with same event, right? So we create a new test event. Understood? We create
Yeah.
a new test event. So event template, right? So you have select some event, no, some key and value. Getting it? So we have some kind of key and value for that, right? So we can simply let that be like that. We can simply come and let that be, for example, right? We may have to give some event name, right? You just try to create, it will not create, it will ask for the name, you see. So just say test event, give some name, test event. Okay, now just say test event. Here you have like event template, hello world. Click on create. Okay, now the test event is created. Test event, here you choose the test event, whatever we have created, that particular event. You can have a number of events. Now you click on test. What does it say? Execution result is succeeded. You click on this details, right? So it says the area below shows the result returned by your function execution. About returning results from your function. Status code is 200. Body hello from lambda. Summary, right? Init duration 124 millisecond. Duration 1.14 millisecond. Resource configured 128 MB. Build duration for 2 milliseconds. Maximum memory used was 51 megabyte. Right? Now, log output. The section below shows the logging calls in your code. These correspond to single row, right, within the CloudWatch log group corresponding to this lambda function. Right? You can click here to view the CloudWatch log group. So here it start a request ID, end request ID, report requested, right? What was the total duration, right? So like that, it is like it is running, right, successfully, whatever we have written in our program, correct? So that is running there, and the information is getting stored in the CloudWatch log. Here, if I go to this CloudWatch management console, right? So here it will be showing AWS Lambda hello team, right? And then we have the log stream here. Right? So you go to this, so you will see here, start request ID, end request ID, report requested, right? So no newer event in this movement, right? So this is giving some kind of CloudWatch related information, right? So logs will be copied here, and then you can just go through it. So what has happened actually? Nothing much was written in our code, right? Whatever we wanted, right, that we tested here, right? So what we have to understand with this lambda is, right, we can write whatever we want to do. Okay, whatever you want to do, right, that you write. Correct. Now you go to this function. This is the hello team, right? So in place of that, hello team, hello from lambda, right? You can just mention something else. Correct. No, you can write something else in the code to create something. Correct. Getting it?
Yeah.
So you can create some kind of function. So what we have to understand is, we can create some kind of function, right? And then that function will be triggered, right, in a particular situation. So recently we were looking at that, auto scaling. You remember?
Yeah.
Now, if we want, right, a particular situation is there, say like when our system is not responding, right? That CloudWatch also we were doing learning CloudWatch, auto scaling, load balancer, and all. So say like load balancer is there, and now it is not listening. It is like it's just trying to monitor one particular EC2 instance, and it found that that instance is no longer listening. It is down. So that time, right, what to do, right? So go to the lambda, run that lambda function. What is written in that lambda function? Create one new instance, right, in a particular availability zone, or based on a particular template, right? Create one new instance. We can tell like that, right? Correct. If somebody tries to do something with my bucket in a particular S3 bucket, then what to do? Just do something. Just alert me. Just give some warning. Just use that SNS topic, that where it will email me, or it will just call me, or it will just message me. So some kind of automation you can do using this lambda. Understood?
Okay.
Understood? Lambda. So this lambda is usually right.
So this lambda, whatever the code we put it, right, will that be able to connect a multiple system? Whatever the system we want to connect it, will it be able to connect?
Yes, why not? Not only system, anything.
Mm-hmm.
See, S3, I gave you one example of S3 photo, right?
Yeah.
So simply, you should be knowing any of the language, whatever language you want, right? And then you simply use that, right, for doing something. Understood?
Yeah.
So you can, maybe you can.
I think I want to use it for mainly for the email purposes, email sending from the
Email
server.
sending
Just
thing, that SNS topic will be there, no? So that will be quickly easy. That will not be, that will be like very simple. But this is like that will be very much limited for it, sending for email and all. That will be very limited. Not for that. For doing very complex things, very big things, which will run for a minute or two, right? And it will simply work, right? Otherwise, what you have to do? You have to create one EC2 instance. You have to write some script there. You have to do a lot of things there, right? So instead of that, you don't have to run it continuously 24/7. Whenever that thing happens, some kind of situation happens. In that situation, you want to use this, right? So what you do, right? You can try to think of a situation and try to use a particular, program, right, based on your choice, right? Whether Java or Python or something. Just think of a situation, right, on your own, right, and try to write that lambda, right, and let me know. Okay. Can you think?
Sorry.
Can you think of a situation, right, in which you can try to create and run a lambda, right? Create a lambda function for doing a particular thing. Whenever CPU utilization goes beyond 50%, that lambda should get triggered. Getting it?
Yeah.
You can do that. Correct, no? See, whenever you can use this for any of the situation. It's up to your capacity, how much code you can write, what kind of programming language you understand.
Okay.
Right. So you can put your code there, maybe somewhere in S3. Let the lambda take that code from S3, right? And anyways, like there will be some IAM role or something will be configured there, right? So let lambda take that, right? And then let lambda run that. You can do that. So it's just like you have to do some kind of practices, right? Start thinking of some situations, right, where you can try to use this lambda. So this is really very powerful, but you will be charged for that execution, right? So we are good as of now for today, right? We are as per the expectations, right? We are going on time, right? So let me just close this recording for now, then we can look at some things.
I just have a query regarding certification.
Yeah, so just give me a moment.
Yeah.